Well, good evening, everyone. Good afternoon. I'm not sure which it is. Um, the class that you're taking part in is a little bit different from a lot of classes you may have done. It is online, but it has no set times, which means there are no um, compulsory classes to attend. So the fact you're here today is totally optional, and I'm glad that you did so. What I'm going to be doing is going over the syllabus, and then I'll be starting the first topic. Right. So I'll be starting the topic. The person who's enabled closed captioning, is it working? Because I may have to do it on my side for it. Not sure it's working. So, okay, it's working. Very good. I should warn you that it doesn't always do what I say or say what I do, whatever it is. So when you read the closed captioning, there'll be a few times where I say one thing, but the captioning thinks I'm saying some other. Well, introductions. As I was saying, this class is online. There is no compulsory classes, so that's going to put a big emphasis on you. It does mean that a lot of your education is going to have to be done through you. Now, the way I'm going to organize this thing is I'm going to be doing lessons on every topic, and those lessons are going to be eventually put online in Canvas. And so if you don't come, you can at least go there and watch a lesson. And it's essentially what I'm doing is trying to make it as close to what would happen if you were in class. So you're going to see me talking a lot, and you're going to see me go over questions, and I will put a link to these lessons so that if you actually feel, and it's totally optional, there's no need for you to do it, but if you feel you want to turn up because it helps and it allows you to ask questions while we're doing it, feel free to do so. And if you are not able to do that, because I can understand that this class was chosen by people who have work schedules and things that really don't allow them to turn up, and that's totally okay. I strongly suggest that you watch the videos, right, at any time that you wish, right, whenever you can get some spare time, and that'll work, and that's how we'll do it. So let's have a look at the first thing, which is go over the syllabus. So I'm going to see, and I kind of need help when I do things that you tell me it's worked, right? I hope right now that you are looking at our Canvas site for our class. Is that what you can see? If someone just says yes, that's enough for me.
Yes.
That's great. Okay. So this is our Canvas site. Where will you find these lessons, right? As the weeks go by and topics appear, you're going to find out they're going to go here. You see these class resources? I'm probably going to put them in here. Now, while I'm in this list, I also have a link here. And this link essentially takes you, it has recordings of previous classes lessons. So you can have two link bites at the cherry. You can see what I did in a similar way. So the thing that's got math class resources has things like Desmos, which I find very helpful to draw with. And some other things like these guys won't really make sense until actually the last week. But Desmos will be used a lot. Now, someone earlier mentioned, do you get to take notes for your final, right? Because the final is, and it's the only time that you're actually compulsory meant to be here. Your final is on ground. So we'll have a look at the syllabus and you'll see in about 5 minutes when and where that needs to be. So you have to book in advance, right? So I want you to go and, check with your boss if it's a job you've got, and make sure that that time is open for you, because that's when your final exam. Everything else, apart from that one final exam that we talked about, is online. All your homework is online, all your online tests are online, you name it, it's online. And so That's why it's an online class, including the lectures. So let's kick over now. Now, there's tons of things in this list. I'm scanning through it. I mean, for instance, if you click on that one, it'll give you some worked examples on a topic called hydrostatic pressure. This one will give you some solutions to finding centre mass, and here's some lectures on PowerPoint for it. So there's a lot of stuff in this Canvas. I don't want you to feel that you're kind of stranded, like, well, I don't know. The analogy would be turning up to class on day one, they hand you a calculus textbook, and they say to you, you're going to do chapters 5, 6, and 7. See you in 10 weeks when there's the final. Right? I don't want you to feel that that's what's happened to you, right? So you can contact me by turning up at those times that I talked about and ask questions, or you can contact me outside of those times, and I'll try and arrange a Zoom office meeting for you. So let's kick into the syllabus. There are no classes. There are no set times. Everything is optional. So there are no holidays either. Well, technically there will be holidays because you'll just take them. We have a whole load of stuff here. One of the most important things you're going to have to do is join WebAssign, because all your homework and everything that you're going to do is on WebAssign. The easiest way to do it is to click on this link. And what this link do, I'll do it partially because I don't want you to actually join WebAssign. That would confuse everyone. If you click on this, you hit the enroll button. And I've been told by other students who've done this, that when you hit this, basically you've entered the class and you register with your email and all that fun stuff. And you get 2 weeks in which you do not need to pay. So if you haven't got a key and you're waiting to get some financial aid together, you're still okay. You can get in here. They'll let you and do everything that everyone else will do for 2 weeks. But at the end of that 2 weeks, you have to pay. And if you do it this way, you'll just be able to pay with a credit card and type in your info and you're good to go. So that's what that guy was like. You could already have bought a key out of, say, the Olympic College bookstore, in which case it's a little bit more involved, but this is the important guy. That is the class key. That makes you go to our class and our class only. And here is a PDF with some more details on it. Here is a list of all the holidays and things. So if it is official holiday, I won't be doing anything either. So there won't be a class lesson produced that day, but I'll be producing those class lessons pretty consistently. The most important thing that you need to know is this guy right at the end. That is your final exam. And I believe, hopefully I've written it down correctly, that it's March the 12th, which is a Tuesday, 8 till 10. And it will be in building 4. If you've never been to Olympic College, all the buildings have numbers. It's in the centre. If you look at that tower clock thing, it's to the right-hand side. And it's on the 3rd floor, room 2, so 302. Now, what you're seeing here is the essential work. So since so much of this is being forced upon you, right, you have to be in charge of your own study, your own things, and putting structure on it. Because unfortunately, if you just say to people, here is everything, you've got 10 weeks to cover everything, some of you will not be good at doing that. So I'm structuring it for you to kind of force you into a kind of pace so that you'll have a certain amount of work each week. It'll give you a deadline and a goal. So for instance, week 1, we're going to cover section 5.1 and 7.7. And all homework and online tests are due midnight of that Sunday of week 1. And then week 2 will cover this, week 3 will cover that as we go through. Then what will happen? We have a midterm. And the midterm is an online midterm. So you don't come to college, you do it online. And it's a biggie because it's worth a lot of points, as you'll find out. And the There is flexibility because it says due at midnight Monday. So you could actually do the midterm Sunday or Saturday or Monday. You could do it Monday at 12 o'clock. You could do it Monday at 9 p.m. But it has to be finished by midnight Monday. And then we do the rest. Week 10, we'll cover those topics. Homework assignment 10, online test 10. And there's actually a project due on Wednesday of week 10 as well. And technically that's just a review. So on that Monday, the 12th, I'll be turning up here, typically at 4 o'clock. And it's just you come in and ask me some questions if you're stuck, if you need some help. And there, repeat. Now that is interesting. That is not the same number as up here. So it's obviously I made a mistake. My gut feeling, in fact, I'm 99% sure that this is the correct one. Your final will be on Wednesday, the 13th, 24. And I will definitely double check on that, but I'm 90% sure. I think all I did is, because I use this template, is I didn't change all the times. So let me go down and jump. Yeah, that verifies it. It is 2 to 4. Right? So that is the schedule. So what is going to happen with deadlines? Now, there will be some flexibility because, you know, some of you probably have jobs and you might end up having to spend, you know, 4 days in a row in the shipyard and really just not have enough time. If you find that you're in a situation where you can't complete, well, let's pick a week 3's homework on time, you will email me and tell me that that is the case. And I'll be flexible. I can add some time to that. But I'm not going to do it every single week so that you're not going to get away with, well, I need an extension for homework 1, and then by the end of homework 2, I need an extension for homework 1 and 2 and 3 and 4, because that defeats the purpose. So I will be flexible, but I won't be, you know, pushover. If you keep asking for extensions, I'm just going to say no. You're just going to have to, you know, bite the bullet. So be aware of that. It's better for you anyway. You do not want to do 5 weeks of homework in 1 week. You will fry your brain. It will not be good. You won't be a happy person. So I am kind of saving you. Okay, I'll pause at that point. Is there any questions?
Yes, I have a question. So I took calculus 1, so it says that we don't need to purchase the book or anything, the hard copy, but I already have the hard copy because I
Well, that's great.
bought it.
Use it. I mean, you spent the money, you might as well put it to good use. But you need WebAssign. So it doesn't replace the WebAssign.
Okay.
Okay, because WebAssign actually has the homework there, but you answer it inside WebAssign. It's a program, it's a portal. And actually, when I finish this, I'll take you into WebAssign and kind of show you what it's like. And so you need to join WebAssign, right? That is something you can't avoid. And you could have a textbook, that's great. If you don't have a textbook, that's still great. You don't need one. WebAssign has an ebook version of it, so you actually got it there if you need it. Okay, learning objectives. What is Calc 2 about? Well, when we finish, you can go back to this and have a look at it. But essentially, Calc 1 was, how do you find derivatives of functions? Right? And what can you do with them? That's basically Calc 1 in a nutshell. Calc 2, the class we're doing, is how do you find the integral of functions and what can you do with them? And you'll find out that there are tons of things you can do with integration of functions. You can, for instance, find the area under the curve, distance traveled, excuse me, work done, volumes of shapes, surface areas of shapes, centers of mass, tons and tons of things you can do with integrals. And we're going to show you how to find these things called integrals. So what we've got here is a list of all the things that are going to be for your grade. 20% of your grade is on your homework. So you do your homework, you get a graded on it, 20% of your grade comes from there. Each week there's a homework assignment, and each week there's an online test, 10 of them all together, and that's 20% of your grade. But there is a slight difference on online tests, and it's not, can't even fix my own mistakes. It's 20, not 25, as you can see. I only count the best 8. So if you have a bad week and you miss an online test because you get overwhelmed, you caught the flu, you can have 2 of them dropped, and it's the average of the other 8 that counts. You can get extensions for homework, but you do not get extensions for online tests. So for whatever reason, if you can't make it for that test, that one's gone. So try not to miss too many of those, because then it will start having an effect on your grade. But if you miss one, it's no biggie, because you get to drop 2. If you have a really bad one, well, we drop that one as well. Another thing about the online tests, when you do them in WebAssign, they're basically based on the week's work that you've done. That's where all the questions will come. They'll look very similar to your homework questions, so there shouldn't be too many surprises there. But do not click on the online test until you're ready to take it, because it's timed. So the minute you click on it, there's a timer, and it will start, and you only get whatever it is, 2 hours, 3 hours to do it, probably 2 hours. And when you've finished, when that 2 hours is finished, it cuts you off. So if you click on it and go in and go, oops, I didn't mean to do that, I'll just go out and it'll freeze, it doesn't. You can leave that and it will still keep going. And then basically that's it. So if you accidentally click on it, do the best you can, because that's all you're going to be able to do. Some things about the homework and the online tests. WebAssign varies the questions. So if you're doing a homework question and you get stuck on it, you can't really easily phone up someone and say to somebody in the class, hey, I'm doing question 8 from section 5.2. What did you get? Because their answer might be 42, but it won't be your answer, because their question was 3x cubed and yours is minus 5x squared, right? Different terms, different answer. The online class tests are varied, and they are grouped. What do I mean by that? It means you might not even get the same question, not just the same question, but with different numbers. You might not even get the same question. In fact, you won't always get the same question as someone else. And that's really for security purposes. We want to make sure that when people do things, it's their work and not they're simply just, they know somebody who's really good, and whatever they get, you're going to write it down and get the same grade. Because that won't happen because of the way it's structured. So you really do have to make sure that you learn the work on your own. And there's nothing wrong with phoning a friend and saying, I'm having problems doing this process. Could you talk me through how to do it? Learn the process. And if you have time, you can go to e-tutoring, and someone in e-tutoring can help, and you can actually go to the college and help. And if you contact me, I'm more than happy to help you with the concepts and the questions. But bottom line, it's going to be your work. There's a guy called a project, which is 10% of your grade. That project will be done on paper. It won't be done in front of me or like the final exam. You'll just do it when you've got time, and you'll write the solution down, and you'll write what the answers are, and you'll upload it and send it to me. And it's basically a practice final, but it is worth 10% of your grade. So you do really want to make sure that you do a good job at it. There's your online midterm exams. We've already covered them. And then your final exam, which is definitely Wednesday the 13th from 2 to 4. I'm sure it is. Okay, I'll pause for a moment. Any more questions? Okay. Oh, got someone in chat.
I do have a question. So is a dumb question, but is there any homework that's due today? Like I logged into the WebAssign and I didn't see any homework due today.
Not any today.
Homework is due to the 28th.
It should have appeared today, but if it's not, it's easy for me to just go back in and I'll get it appearing today once we're finished, right? It should have appeared, but if it hasn't, I'll make sure it does. In fact, I'm sure it has, because we're going to go into WebAssign in a few moments from now and you're going to see what I see, which should be student view. So hopefully you might want to update your page, because sometimes your page, your internet browser caches your pages in where it uses, the last time you were in, and if things are updated, it doesn't always do it well. So that might be the issue that I'm thinking about. Any other questions? Okay, so what do you need? Well, you collect all those points that we talked about, and you get a percentage. And the key number for you is, as a class, is 75%, which is a 2.0. And to get that, it will allow you to move on, and if you need to, at least do the next class. So that's what you want to work on. And that's what your grade looks like if you do a decimal grade on it. Now, since you're online, some of these choices may not be available to you, but the college does provide a free service called e-tutoring. From other students, I've been told it's a little bit hit and miss. Sometimes it's good, sometimes it's not so good. But it is a source that you can go and ask people help on your homework, which is totally okay, right? Let them work through the questions with you, show you how they got the answer. I'm cool with that. As long as you're learning, that isn't cheating, you're fine. And some of you might know each other, in which case I'm calling them study partners, so you might phone a friend. You can see me. I have an office there, which you'll find the link to at the top, which is at different times of the day, Monday to Friday, but you can see a schedule. If that doesn't work for you, you can just turn up, say 4 o'clock, like we are today, and we can do that. Or you can email me and we'll find some suitable time that we both can be free, and I will do a Zoom meeting with you, so you can do it online. Right, last thing, we kind of covered this. To get to Calc 2, I'm assuming that you've already got a pretty good work schedule. You know how to do college. So keep to the class schedule, right? Make sure you do week's one's work by the Sunday of week 1, week 2, week 3. If you keep that up, it will spread the work evenly throughout the quarter and you won't get overwhelmed. Plus, it will give you enough time to actually study the stuff as you're doing it. Seek help any way you can, and don't do your homework. Don't do it Sunday at 9 p.m. That is just not going to work. I mean, if you get a problem, you're stuck. You have no time to fix it, right? Yeah. And remember that you still have an online test to do. And that really isn't very good idea. I suggest instead is, if you've done a topic, you've done all the homework, you feel good about it. If you've done the second topic, you've done all the homework and good about it, spend a little time just going over those homework questions. You know that the test questions are going to come from similar looking ones. Once you feel good about it, maybe, do it the next day if you want to rest, then do it. Sunday midnight is not the day you need to do it. You could do it Friday or Saturday morning, whatever you want. And that is me finished the syllabus part. Are we good to go? Any questions? I've got something in chat. What have we got? Yeah, the exam dates do vary. And you say here, someone else has said, I already have a class on campus from 2 to 3 on Wednesday. Okay, what we're going to have to do with that is, because times, unfortunately, online especially, the way it works, clash a little bit, is that you're going to tell me what that is, and we will fix a time more than likely earlier, so you can do my class and then you can do that one. So we'll figure a thing to do sometime on that Wednesday for those of you who that is the issue. You're welcome, Michael, not a problem. Any other questions?
When will your lecture videos be uploaded?
The way I do it, it takes a lot longer than you think, but I have to edit them. Sometimes the reason I edit them is that at the end of today, for instance, some of you might want to talk to me about something you don't want the rest of the class to hear. And so I need to edit my videos and cut out bits and recompile it. And basically, the following day is a good judge. So this one that we're on right now, that will appear Wednesday in Canvas. And there'll just be one link, and inside that link, all the videos will be. And so when you click on it, you can go inside and see today's and topic 1 and topic 2 and all the other topics that come after that. Okay?
Okay.
So typically, day, if I catch the flu or my wife decides that we have to go out, it might take 2 days, but that's pretty rare. So let's leave this fella for a second. Let's go home. Before I leave this place, college resources, you may need some help, library services, getting help, you're having issues with Canvas. There's all the good stuff that the college provides. We don't just provide homework help. We provide, if you're having a really hard time, and you need someone to talk to, we have counsellors that can help you. If you're having housing issues or whatever, we have those resources, right? So there's lots of people that are here to help you. We do try as best we can anyway to help our students. So if you click on that one, let's do it and see what it takes us to, right? Here are some of the disability support, institutional, and some of the things that you can do. As you know, we've got counselling and so on and so forth. This one up here is basically help on using Zoom, which the fact you're here kind of means you know how to do that. A little bit of information about me and how to join WebAssign. And the information that is in WebAssign is duplicated in the syllabus, so you should be able to get it from either place. And there's some fun stuff. And I just realized I didn't introduce where I'm from. Does anybody know where I'm from?
I'm gonna guess Scotland.
You nailed it. I am from Scotland, yes. So you may have picked up what you think is that I have an accent, but actually I don't have an accent and never have. Neither do all my siblings. And when I go home to Scotland and I talk to people in the street and so on, none of them have accents. So from my perspective, I have no accent at all. And if that confuses you, how about you lot do have accents for me? And your accent is American accents of various kinds. So does that matter? Not really. Most students will tell me after they've had me for about a week, it's just a funny way I talk. They just get used to me. I would hope most of you are good that way. I do have a couple of idiosyncrasies. I might occasionally use words you're unfamiliar with, but it's pretty rare. I'll say something's wee, which means it's small. Or I might say, I'm going to do this, which just means I am going to do this. Apart from that, Z and not Z, and J, not J. And those two letters of the alphabet are my letters. My alphabet was my alphabet before it was Americans. So I am right and you are wrong. Oh, a couple of you pretty much guessed it, yes. So that is what you've got for Canvas. That project that I mentioned this year, forget the date because it will be changed to your date. And this stuff here will appear when we're closer to the final. And what I'll put here is examples of past final exams and so on. So you get a little idea of how I ask questions and what's expected of you. Are we cool? Any last minute questions before we go on and look at WebAssign?
For the final, it says that we're gonna get a comprehensive formula sheet. Is
Yeah,
that
would you
something
like-
that we can use for like the midterm and stuff too, to
Sure.
kind of practice
Yep.
with it?
Yeah, let me show you what it looks like. There it is there. So on your final, you're not allowed to bring notes, but what you'll get is this page, which is a list of what we call standard integrals, some trig formulas. That's what you get. And I should actually double check that because I'm pretty sure there's another part of it that's not here. Yeah. There is a third page to that, but I don't know where the heck it's gone, but I'll make sure it's in. The first page, standard integrals. Second page, trig formula. Some reason the third page hasn't made it, probably made a mistake uploading it. But the third page contains the formulas that you will be using. And there's not really that many of them. In fact, I think now that I'm thinking about it, I don't even typically put that down because there isn't that many formula. And any time that you need a specific formula that's a little bit different, I may put it here, but I'm just as likely to put it in the question. So use this formula to calculate, the century mass, for instance. So that's what it looks like right now. I'll check. I might have a third page. I'm not 100% sure. Sometimes I do one and sometimes I change it and I do it the other way. But these two are definitely going to be there. They're standard. Right, let's have a look at do a quick stop the share and let me have a quick, there we go. And let's show you WebAssign. So this is essentially what WebAssign is going to look like. You'll notice that it's already got the first week's homework sections, 5.1 and 7.7. What you don't have yet is online homework 1. I won't make that available till a little bit later in the week, just in case people who haven't been to this video and haven't heard it yet might accidentally just go in and have a look at it because they think it's okay and they don't realize it's time. So it's just for your protection. But I will, once this video is up and running, I will probably put it live on Friday and you'll be able to get it. But typically I'll put the work and the online homework visible all at the same time, so that if you, I don't know, your work schedule, if you can say, look, Monday, Tuesday, Wednesday, I'm really free, that's when I do all my stuff, then it'll be there for you, right? And you might be, I'm a Friday, Saturday person, right? So it's still going to be there for you. So I'm trying to make it as flexible as I can. So let's take you through how WebAssign works, in case you've never done it before. It's basically online homework, and that should have clicked by now. There we go. And so you get a question, and you put in answers. And let's put in an answer that I know is totally wrong. Let's suppose that that answer was 42. So I went and found the area of all these rectangles and added them up, and the answer I got was 42. I'll now go and submit answer. And if it's right, it'll give me a little green check mark. But you notice it's wrong. So it has a little X. So what you do there is you, oh, don't give me a fright. No, bugger. Did you get a fright there? Oh, she backed anyway, she's schooled. So where was that? You get 5 guesses. So if you get something wrong, do it again. Maybe you'll find your mistake, put in the second answer, put in the third. After 5 answers, you've lost it. That question is dead. You've lost some points. So round about the third wrong one, you might want to start looking at some help. So let's give you an example of some of the things you can do. When you've put an answer in, hit submit answer, right? And that's what I did to check. Where is it? To check that one. And then you put in a new answer, 78. And when you're happy, you submit answer. It's obviously wrong because I'm guessing it says. You can hit this thing, practice another. What that'll do is it'll give you a very similar question that, well, if I click on it, we'll see what it looks like, right? See it? Very similar looking question. And you can put in your answers. Again, I'm just randomly picking numbers. Right? And they'll just say, grade this. And you can do as many shots at that as you like. And then once you've figured out what you've done wrong, you can close this off and you can go back to this original question, the one you were getting in trouble with, and do it. In some of these questions, you'll have watch a video. And so you can actually watch a video and someone will take you through the steps as well. You see that little guy there? Watch it. There's an example of it. So you click on it. Somebody's then blah, blah, right? And so if you hit read it, it will take you to the ebook and then you can read through it. So again, you're not left out to dry. Do you see that you can have sometimes anyway videos to watch? You can practice another, you can read it from the textbook. You can do e-tutoring. There are tons of ways of fixing a problem. So don't let, something just say, I don't know how to do that. I'm just going to ignore it and move on. It's much better for you if you essentially you do it and you get it right. Because math is very linear. You need to know topic A to be able to do topic B, which then leads on to topic C. And if you have a gap, it just causes problems later on. And here's a whole list of questions, which is fine. And we are going to now, again, I'll pause. Is there any questions about how WebAssign works and what do you do? Okay, I'll take that as everything's good. Right, I need some help again. Are you looking at my two hands and Math 152 online? Is that the screen you can see?
Correct.
Yep.
Yeah, okay. So, imagine that instead of sitting at home or wherever you're sitting, you're in class. This is almost what I would be doing, right? So, I would say, hello everyone. We are going to start today with the Intro to Calc 2. And the Intro to Calc 2 began by solving this problem. And the problem is called finding the area under a curve.
Is that
So,
Riemann sums?
It is, yes. Riemann sums are going to be your go-to guy. At least the Riemann sums is a notation that takes the process and condenses it into a little package. It's helpful. And we do a little bit, but not much of finding the exact area of under curve using a Riemann sum. But thankfully, we don't do an awful lot of that because, well, it's very time consuming and quite messy. We're going to look at this guy then. How do you find the area under a curve? Going back, you remember doing Calc 1? It began by solving a problem called the tangent line problem. What they had in that world was, hey guys, here is a curve. I want to know the tangent line at the point x1, 2. And it took about 2 weeks. Didn't we go through finding more and more accurate ways of estimating what the slope is? And then we moved on to a process called limits and spent a lot of time understanding how limits work and how to calculate them. And then at the end of that, we had a formula that used limits that allowed us to get the exact value, right, for the slope of a tangent line. And that became the derivative function. And that was Calc 1. Well, Calc 2 has this thing called find the area of a curve. So I'm going to show you what it looks like. Imagine, and I'm picking a nice easy curve because I want to make my life simple. Suppose you had the curve f of x equals x squared. And let's suppose here is 1. And here is 3. Right? When you're being asked to find the area under the curve, what we are asking is to find that shaded area. That's what we mean by the area under a curve. And so it was a problem. It was one of the kind of the fundamental problems of calculus, right? People said, look, I want to find this area. And you might say, well, you know, I can't do it exactly because it's not a triangle or a rectangle or a circle or a bit of a circle, because they're really the only shapes that we know the exact area of because they've got formulas, right? A rectangle is right length times height, right? A circle is pi radius squared, right? And a triangle, well, half base times height, right? But this curve here isn't part of a circle, although it looks like it might be. It's just a curve. And so to find the area of that, we had to approach the problem, and we're going to approach it in 2 ways. The first one, which is all we're going to focus on for the first week, for the most part, is we're going to find ways to estimate it. So I might not be able to find the exact area under that curve, but I should be able to find an estimate for it, right? You know, say like it's 8 or somewhere between 8 and 9, right? That kind of thing. And there are ways in which we can do that. And that's what we're going to focus on, how to do an estimate. Later on, we're going to do the second way. And the second way is we are going to use Riemann sums, as someone mentioned, to find the exact area. Well, let's look at that guy and say, I wonder how we could approach this problem. So let's approach it from a practical way. What you could do is split the shape into 4 things called strips. So this is 4 strips. And the number of strips, we call it n. So if somebody says, I want you to use or find the area under this curve, and I want you to do it with 10 strips, that would be n equals 10. Or 4 strips, n would be 4. So it's easier to say n equals 4, but they could say n equals 4 strips as well. Right? Now you might say, well, what you've done here is just break the job into finding the area of 4 strips, or at least estimates of them. So imagine that same curve again, something like this. Here is the start. Here is the finish. Here is 2. Here is the 1. Here is 1. So that's the shape. I'm just doing it again because there's just too much going on to see it. Well, this shape is built into 4 strips, and I am going to find an estimate for the area of each strip, and then I'm going to add them all up, and that will give me an estimate for the whole shape. Does that seem a reasonable strategy? Yeah, pretty reasonable. Okay, let's focus on strip 1. This strip here, I don't know how to find the area of this shape. I'm going to pick the simplest shape that I know, and I'm going to pick a rectangle because I can't think anything simpler. And for this rectangle, I have a choice. I can use the left-hand side, right? This guy here, which is the one I'm going to use. And I'm going to use its height to be my estimate. Now, if I find the area of that rectangle, which I can do, would you agree that it's a little bit smaller than the real area? But at least it's an estimate, right? Now, if I do the second strip, since I chose the left side, I'm going to choose the left side again. And that will be my second one. And for consistency, we need to do the same for all of them, right? There's my third strip. And then here's my last strip. Every single one of these is a little bit smaller than what the true answer is. And the reason for that is, can you see these little almost triangular bits at the top? They're not quite triangles because it is still curved, even if it's slightly curved. But they are missing. So these are a little bit short. But that does mean that my estimate of what I get when I get these four and add them up, that estimate will be what we call an underestimate. Which means it's smaller than the real area, right? And now to introduce you some notation. There are 4 strips in this estimate, and we used, for each one of them, didn't we use the left-hand side, right? The left side to get the height. We call that guy L4. So if you get a question, which you will in the homework, that says, find L4 or find L6 or find L10, you see they want you to use, let's say it's L4, 4 strips, and for each strip, use the left-hand side. So far, so good. Now, I'm going to do another estimate. There's my first strip again, but this time, I'm going to use the right-hand side. And when I use the right-hand side, at least in this question, would you agree that all my rectangles are bigger than the area? Right? This entire rectangle is now going to be used for my estimate. This one, and finally that one. We would call that one an overestimate. Do not overthink this, but I'm going to ask the question anyway. What name do you give to an estimate that uses the right-hand side to get the height of the rectangle? Yeah, correct. R4. Okay, let's actually take this function, f of x equals x squared, from 1 to 3, calculate the area of those 4 strips, right? Add them up, find the area of the figure of 4, add them up. And when we do that, although I don't know the exact area, there is something I do know in this particular situation. Let's just pretend for the argument's sake that this is 10 and that's 12. Since 10 is an underestimate and 12 is an overestimate, right? Underestimate, overestimate. Doesn't that mean that the true area is somewhere between 10 and 12? Between the under and the overestimate. I saw someone saying that the first rectangle is an overestimate. Looks the same size as the second. Yeah, I just drew a very bad curve. There's no reason that they will be directly, I think. Let's check that. Oh, you're right. There will be, which is okay. You're right. And if you didn't see what he's saying is, do you see this big rectangle here on the first one? Isn't it going to be the same size as that one? That's interesting, but it's true. Okay, let's see what else we need to do this. Since I need to calculate the area of these rectangles, I need to know how wide they are. And the width of a rectangle is called delta x. That's the notation. The difference in the x is the width, delta x. And the formula for it is b take away a over n. And if you're wondering who is b, it's 3, and who is a, it's 1, and who is n, 4 strips. So that ends up being 2 over 4, which is 0.5. So I can go here and I can tell you that's 1.5, that's 2, that guy there is 2.5, and that's 3. Are you comfortable about how I now found what the x coordinates of each of these start and finish points are? Now, if I'd said from 1 to 3, but do 10 strips, let's just pretend I did that. From 1 to 3 and I did 10 strips. Delta X would be the finish, take away the start, divided by n. 3 take away 1 divided by 10. 2 divided by 10. Delta X would be 1.2. So this guy would be 1. Then it would be 1.2, 1.4, 1.6, and so on. You see, if by the time you're finished, you would have 10 strips. Any questions so far? Okay. Now, since I'm going to find the area of the blue ones, right, L4, how would I do that? Well, L4, let's take the first rectangle. It's 0.5 times its height, and its height is the value of the function at 1, which is what, x squared of. Then the second rectangle is 0.5, the height of the function at 1.5, 0.5, the height of the function at 2, and last but not least, the fourth rectangle is 0.5 times the height of the function at 2.5. Now, when you look at that, I hope you notice that every single one of them is 0.5 times the value of these fellas, which are basically the heights of the 4 rectangles that we're going to use. And someone's saying, well, since f of x is x squared, won't f of 1 be 1? And it is, so let's do it. 0.5. 1 squared is 1. The value of the function at 1.5 is 1.5 squared, which is 2.25. That guy is 2 squared, which is 4. That guy is 2.5 squared, which is 6.25. And so it's going to be 0.5. That plus that plus that plus that, what's it going to get me? 10, 10.5, 12.5, 13.5. And that's going to get me 6.75. I now have found my first estimate for the area under that curve. It is 6.75. And I already know that that is the underestimate, which means the real area under the curve is 6.75 or bigger, more likely bigger. We good? Now, let's do right 4. These are very time-consuming questions. I don't think they're difficult, they're just time-consuming. To do right 4, these will be the red guys, right? Now, if you look at them, it's going to be 0.5. Now, I'm not going to put this line in because I know what's going to happen. For the first rectangle, aren't we going to get the value of the function at 1.5? For the next one, it's the value of the function at 2. For the next one, it's the value of the function at 2.5. And finally, for the last one, it's the value of the function at 3. And then that guy is 2.25. 2 squared is 4. That guy is 6.25. And 3 squared is 9. And that's going to get me 8.5, 10.5. I believe it's 19.5. And that's going to get me 9.75. And we already have decided that this is an overestimate based on the geometry. So I can say this as well. The exact value for the area under a curve is somewhere between 9.75 and 6.75. And I guess for an engineer, that's good enough. But it's not great. Would you agree? There are a lot of places between here and here that it could be. Right? But at least I know it's somewhere between them. So once this process was set up, that you can break it into strips and use the left side to get L10 or L4, and then the right side to get R10 and R4, you might say, well, how do we improve? How do we get a better estimate? Well, L4 means I use 4 strips. So here's a truism. If I used 40 strips, would you agree that I would get a much more accurate answer than just using 4 strips? Does that seem reasonable to you? Yeah. And that's exactly what we do. Well, we don't do it. Can you imagine that you would get a computer program to do it? And that makes life so much easier. For theoretically, it wouldn't be that difficult for any of you, if you are computer science majors, to write a program that would essentially do what I've just done here, with the only difference being that you would have a variable called n that you could make 1,000,000, which would mean 1,000,000 strips. And so you would get the computer to do 1,000,000 rectangles and add them all up. And L1,000,000, R1,000,000. And you would be able to narrow that down to like 8 decimal places. So you'd be able to say, this is made up. Oh, actually, it's not. I can tell you the right answer. If you give me a few seconds. 9, take away. The correct answer is 8.6. So you would be able to say something like that. Yeah. The real answer is somewhere between 8.61 and 8.7, or somewhere between, 8.699 and 8.7, whatever it happens to be. And that's how they get round the technique for finding the exact area, or an estimate for the exact area under a curve. You do a left 4 or a right 4, or an L10 or a right 10. Now, in this world, this function is increasing. Can you imagine you were doing a curve from 3 to 7, right? So you're getting that guy. Since this curve is decreasing, if we split it into guys, and I do an L8 and an R8, one of those two is going to be the overestimate, and one of those two is going to be the underestimate. When the curve is increasing, the L is the underestimate, and the right is the overestimate. But when it's decreasing, the L will be the overestimate, and the right will be the underestimate. Does that make sense to you? So if the curve you're trying to find, the area under the curve, is an increasing curve, the left is an under, and the right is an overestimate. If you have a function that's decreasing, it's the opposite. And to try and convince you, let's pretend I just did one strip. There's one strip. If you use the left-hand side, do you see how the rectangle is going to be bigger than the area? So the left-hand side choice generates rectangles that are bigger than the true answer, overestimate. Now, suppose you had a curve, which most curves actually do this. And let's suppose that's 1, and let's suppose that's 10. And you break it into strips, as you will every time. Can you see now that you cannot say that the left or the right are over or underestimates? Do you agree? At some places, they're overestimating, but then later on they're underestimating. So for instance, if I choose the left-hand side, right, to do my rectangles, can you see how some of my rectangles are overestimates, but others are underestimates? In a way, that's kind of helpful, because once some of the overs cancel out some of the unders, so your estimate will probably be a little bit better. But that means that you no longer can do this property. Because couldn't the L8 and the R8 be, they'll be different, but there's no guarantee that one's an over or an under. They're just estimates. One of them might be better than the other in different curves. One will be better than the other, and then other curves, they switch places, and the left is a little bit better estimate than the right. But there's no real way of predicting. Are we good? Any questions? Got anybody? Nope. So what I'm going to do now is show you some tricks of the trade that can reduce your workload a little bit, because as you can imagine, that was a very simple curve and that took a lot of working. Even although when you go to WebAssign, the only thing you type in when you're finished is 12, you know, the final result, or 12 and 14, whatever it might be, you still have a lot of work to do. So let's suppose we make life really ugly. Right, that is a ridiculously ugly curve. It's probably going to zigzag up and down. Let's suppose we do its value from 0 to 1. And let's suppose that we do 5 strips. And I would like to find the estimate L5. And I also don't want to have to do a whole load of this. Is there a way that we can come up with the same result, but more efficiently? And the answer is yes. So first thing you're going to do is you're going to find out what delta x is, the width of a rectangle. It's b take away a over n. And a is the start of the interval and b is the finish. So in this case, it's 1 take away 0, and the strip is 5, and 1/5 is 0.2. And now I am going to create a table. And that table is going to contain all the numbers that I need to get L5. But I don't want to have to go to my calculator and type that guy in with x equals, well, I know the first value is 0, right? I don't want to have to do it with 0, 0.2, 0.4. I mean, I could, I just don't want to, right? It's boring, it's time consuming. So how do we get around that issue? Well, we can use our calculator. I'm about to do that. And hold on a second. That is not what I want. Turn it in space. Evidently, when you're on Zoom, the thing goes wonky on you. Right. So if you bear with me for a second, I'll get that one to go away, I hope. End task. Okay. Right, let's do the emulator again, and I won't put in the other guy. There we go. Are you looking at a TI-84 calculator emulator? I need a yes, kind of happy face.
No.
You're not? Okay, so that is what I needed to know. So I am going to Get that calculator. Are you looking at it now?
Yes.
Right, okay. So you have your TI-84, and it's great if you can get a hold of one. Let's set up how to find that table without doing too much calculations. First thing you do is hit y equals. And the function that we were going to do is x squared, the sine of x, divided by, and since it says x plus 1, you need to put a bracket around it to get order of calculations correct. Right, that's the function, right? Whatever you're trying to find the area under the curve goes there. Next thing you do is right above the window, do you see this thing called table setup? Blue button, hit that window. And table start is where do you want your table to start? Now, since my table starts at 1, that's great. But can you imagine the next question, it's from 1 to 10 or 2 to 7 or something. Then you'd put 2 there or whatever it would be. Table setup is essentially the delta x. In this case, done 0.2. So delta table is your delta x. Right, that's that done. Make sure that these two say auto, and we are ready to go. Right at the end here, they have a guy called table. So I'm going to go second table. Right, and bingo. Do you see that we have got all the numbers that we need and some we don't need because we only need 0 to 1, and they're here. Now, from what I can see, it looks like I've got 4 or 5 decimal places, but if you cross over and go down, can you see I can get it to 10 decimal places if I need it, right? I'm going to pretend, because I want to make my life and your life easier, that for these questions, that you only need to do the answer, say, to 3 decimal places. So 0, 0.2, 0.4. I'm filling the table in. You'll see it filled in. I'm finished here. And that's 0. To 3 decimal places, 0.007. And the next one is 0.45. And the next one is 0.127. And last but not least, at 1.0. And where is it? It's 0.421. Right, let me make that guy go away. Stop that share. There. Are we back to seeing my whiteboard? Can you see this whiteboard?
Yes.
Oh, good. Right. Now, do you see where I got those numbers? Right. Can you imagine that you were doing 10 strips, so it might be even more worthwhile, right? Now, how do I use this table of values to find L5? Or is it L5? Oh, shooting space. That explains why things didn't look quite right. I forgot one of my answers. 0.8 was 255. Here we go. And then the last one is 0.421. Yeah, that's it. That guy go away again. Right, now, how do I get L5? What you do is delta x, which in this case is 0.2. And you have a whole load of guys that go here. But the guys we're talking about to get L5 are the first 5 guys. Which I haven't done that. Right? These guys. So 0, 0.007, 0.045, 0.127, and the last one is 0.255. So it's delta x, this guy, times those 5 guys. And then I'd go to my calculator, I'd add these all up, and let's see what we get. 0.2, 7, 12, 19, 24, carry 2, 2, 6, 8, 8 and 5 is 13, carry 1, 3, 4. That guy. And that guy times that guy is 0.0868. We're done. Now, if someone said, find right 5, the work's already done for us. If you're doing the right-hand side, don't you pick these guys? Those ones. So I won't do the whole calculation, but won't it be 0.2 times that guy plus that guy plus that guy plus that guy plus that guy? And then you're done. And this would be my left estimate. This would be my right estimate of 5. That's the most efficient way that we can do these questions. No matter how you do them, you're going to have to use your calculator a lot and add a whole load of things up. But at least it takes care of the table values pretty quickly. And then all you need to do is add some things together and multiply by del x, or add these guys together and okay, multiply by del x again. Any questions? Okay. Just double check. No, okay. Let's suppose I had a different question. And L10 was 25 and R10 was 32. And I would, neither of them is an over or under estimate, right? It's just a curve that goes up and down, up and down. We can't make any predictions. If I wanted to use these 2 results in such a way that I could come up with a third estimate that is probably going to be better than either of these 2, and your job is to create that estimate, what do you think would be the simplest way of coming up with a single estimate that uses these 2 numbers? And someone typed in average, and that's what you do. You add them together and have it, the average, which in this case is what, 57 divided by 2, which is 28.5. And we have a name for that guy, and he is called T10, T for trapezoid. So we can do a left 10, we can do a right 10. If we add them and half it, like take the average, we now have a guy called T10. And a truism is that in almost, with a very few exceptions, so you can almost treat it as guaranteed, T10 is a more accurate estimate than either of these 2 in general. And it doesn't really require that much extra work. If you've already had to find these 2, which typically you do, would you agree finding this one isn't that big a deal? It's really just add 2 things and half. Are we cool? And I'm just like any other question or an answer. Oh, yeah, you're right, Andrew. It is the average. Okay, now, if we don't have any questions at this point, I'm now going to move over to WebAssign and kind of show you what WebAssign, how it asks questions, because it has its own kind of unique way. And basically, hopefully we can get an idea or some insight into some other topics that we haven't covered. Right, first things first, are you hopefully looking at Cengage WebAssign the homework. Are we good? Anybody? Yes, no, maybe? I get a chat, so hopefully it's somebody saying yes. Yeah, okay, we are good. So I know that you can see this. Right, in this question here, you're not given the formula for the function. All you've been given is that graph. So do you know that little table that I made, right, with the x values and beside the height of the function, the value of the function? We are going to create this. So let's see what we're going to do. And it goes from 0 to 10. Give your answer to one decimal place, which is fine. And how many strips do they want? There we go. Do you see it? 5 rectangles. So if you look at this shape, 1, 2, 3, 4, 5 rectangles. Great. 5 rectangles. Now, for each rectangle, we need to know what the width is. Well, if you go from 0 to 10 and you split it into 5, you get 2. So 0, 2, 4, 6, 8, 10. So although you can't see it, that's what I'm writing down right now. 0, 2, 4, 6, 8, and finally 10. And next to it, I'm going to do the value of the function. But we don't have a formula. All we have got is a picture, which I don't know if you've ever used WebAssign, but if you click on WebAssign, it actually gives you a verbal description of what's going on. And if you look carefully, I don't know how easy it is for you to see on your screen, but it's telling me that at 0, the function is 5. At 2, it's 3.9. At 2, it's 3, I should say. At 4, it's 1.8. At 6, it is a 1.1. At 8, it's 0.7. And finally, at 10, it's 0.4. And the only one I kind of screwed up was 2.1, which I'm now going to write in as 3. So I'm now going to stop sharing for a minute. Now, so do you see that this table was created not from the calculator, but just by reading off values from the graph? Now, if you want to find R5, it's going to be delta x. Now, delta x, we already calculated that. It's 2. You can see it. 2, 4, 6, 8. So 2 times. If you want R5, you're either going to use the first 5, here, to represent the height of the rectangles, or you're going to use the last 5. Which one gets you R5? Using these heights or using those heights? Which is it? Okay, and someone agreed, it's these ones. So what's that? It's going to be a 3, a 1.8, a 1.1, 0.7, and we finish with a 0.4. And that's 1.1, 2.2, 3.2, 4, 7. There's my R5. Okay, let's do an L5. 2 times these guys then. 5, 3, 1.8, a 1.1, and finally a 0.7. And that's going to be 1.8, 2.8, 3.6, 6.6, 11.6. And that's going to be 23.2. Now, I'm going to go back to the picture. Oh, did I screw up? Oh, we're good. I'm going to go back to that picture and do something else. On this shape here, They're asking you for the lower estimate. This function is decreasing, okay? Is the L5 or the right 5 the lower estimate? It's not really meant to be a trick question. What would it be? Well, I can't tell if someone's answering, so I'll assume that you are, because the way things are, I'm blocked out of responses. The smaller answer is going to be the right guy. And the right guy, I believe, if I counted it right, was 14. Let's do a submit answer. Yeah, we got it right. Now, what they have here is, what would it look like if you actually drew the curve and you put the strips in and you were doing the underestimate one? It's not this one, too many strips. This one looks good, too many strips, and that's definitely an overestimate. And this one here is an overestimate. So I would suggest that that shape would be what R5 would look like in this story. Let's double check it. Submit the answer. Yeah, it's a little bit weird. Although that's the correct answer, they don't put the tick next to the picture. They put the little green tick over here. Now, you want an overestimate, an upper estimate, then 23.2. Again, I hope I did my calculations in my head accurately. And if you want to do an overestimate, it would be this picture. So submit my answer. And it worked. And then it says, find new estimates doing 10 rectangles. Thank God I'm not doing it. But if you wanted to do 10, you go back here and click on that. And can you see that you're now going to go 0, x is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You'd essentially just have a picture twice as big as the table I've got. So instead of 2, 4, 6, 8, 10, you'd go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And you probably would be getting annoyed by then. I would, because I don't like doing calculations, but that's kind of what we have to do here. And you get your answer. And someone did have a comment, and yes, you were right. So left and right. They haven't asked you yet, but if they asked you for T5, wouldn't it to be the average of these two guys? So 14, 23.2, and then you half it, and that would be 37.2, and you half it, that's 118.6. And that would be an even better estimate than the over or the under. And as you can see, it's halfway between these two, which would make sense, is a good place to be a better estimate. Let's return now to our guy. Now, in this question here, they're giving you the function. They're telling you to start at -1 and finish at 2. So this question would be the one that you would do using the calculator method that I showed you earlier, right? So you would go to the calculator, you would type in 2 plus 2x squared, start at -1. The only thing that's missing here is what delta x would be. So if you're doing 3 strips, as we are here, if you do 2 take away -3 divided by 3, the delta x would be 1. On the other hand, if you do 6 strips, the delta x would be 1 divided by, what would that be? Well, it'd be 0.5. Yeah. Yeah, that would be 0.5. And then you pick whichever picture is the 3 stripper and whatever picture is 6 stripper. And then the answers for left and 3 and left 6 going here. And we're on a new guy, so I need to show you. Right now, we have done left, right, and trapezium. So who's left? Well, let's pretend it's 5. Left 5 and right 5 are equally good or equally bad. If you use those two, you can get a guy called trapezium 5. He's better. There is another guy, this new guy. He's called midpoint 5. Let's look at how you get midpoint 5. First thing I'm going to do is try and show you visually how we do this. So imagine we've got our y equals x squared, right? Our function, like before. And let's suppose we start at 1. Here's 2. We finish at 3, right? So it's pretty much the same as we had before. Let's suppose I want to find mid 4, right? So if you go here, you get 1.5. You go here, you get 2.5. It looks just exactly the same thing you would have done, the same setup for a left or a right 4, right? Here's the difference. Imagine we blew up that piece of the shape, right? There's a 1, there's a 1.5. We used to pick the left-hand side and get a rectangle, or the right-hand side and get a rectangle. Fine, you know what you do. But for midpoint, you don't choose that guy, and you don't choose that guy. To get the height of the rectangle, you choose the x value halfway between the start and the finish of the strip, the midpoint of the strip. And there is going to be my rectangle. And if you look, you might understand why the midpoint is better than anybody else. Because isn't this bit missing and isn't this bit extra? They're not a perfect balance, but would you agree that they at least partially cancel each other out, which means that the area of this mid rectangle is going to be better than a left or a right? Does that make sense? That this midpoint trick gets us an even more accurate answer for the same number of strips that any of the other methods we've talked about would do. Anybody want to throw in a seems reasonable or nope, don't make sense to me? Any choice? Anybody got an idea?
How do you put that into a, like, we did the table for the
Ah,
left,
right. How do we
but
make
how
this
would you do it
table?
in a calculator?
Oh, great question. Are you cool that it isn't more accurate? You just don't know how to do it yet, right? Does that seem reasonable?
Yeah.
Right. So let's show you how you do it. This is going to be my table. Now, normally you have 1, you have 1.5, but to get the midpoint, don't you basically take the average of the two? So are you comfortable about where the 1.25 came from? The first length. Right, halfway between 1 and 1.5. Now, how do I make that, use that on my calculator, right? And it's actually a lot easier than you might have thought. So, give me a few seconds to get my calculator set up. There we go. And I'll do it right now. I have to kind of, I got a lot of windows open here, so sometimes, right, are you looking at my calculator?
Yes.
Great. Now, y equals is whatever the function is, right? So it could be that function, it wouldn't matter, it still works. But the one I chose to pick was x squared, right? So, oops, there we go. There we go. Now, table setup. Let's forget about table start for a second and just jump ahead to delta x. Although the shape's not here, isn't the rectangle still 0.5 wide, right? 1 to 1.5. The width is not changed. So we make sure that that is still your delta x, right? All we do is fix the start number. The start number isn't 1. The start number isn't 1.5. The start number is 1.25. Whoops, for some reason I didn't do that right. Let me clear that out. 1.25. So what you need to do here is you need to actually write down the first point, write down the next one. So write down 1 and 1.5, calculate what the midpoint for that is, 1.25, and put it there. And that's it. Let's get our table of values now. Here we go. So I'm going to write these guys down. That's 1.25, 1.75 is the next x value. The next one is 2.25. The next one is 2.75. Right? And we are finished. And I'm going to stop that sharing. And I'm going to fill in the table a little bit more. That's the first midpoint, that's the second midpoint, the third midpoint, and the fourth midpoint. Do you notice that they're just delta x difference? Now, that 1.25, and I'm going to do it to 2 decimal places this time, 1.56, 3.06, 5.06, and finally 2.75, that's 7.56. Now, here is our table. Do you notice that when you do midpoints, and you're doing, as we are, M4, that your table has 4 numbers in it. If you were doing M6, your table would have 6 numbers in it. If you're doing L10, God forbid, you have to 10 numbers in it. And the formula is delta x, which is 0.5, times the height, plus the height, plus the height of the third one, and finally, the height of the last one. And so it's 0.5, 1, 2, 3, 4. That's 4 carry 2, 7, still 7. Still 7. 12 carry 1, 2, 3, 4, 5, 10, 17. And that ends up being 8.62. And that's how you would get a midpoint 6. Create the table, or midpoint 4, I should say. Create the table with 4 numbers. The delta x is still the same delta x, right? From here to here is still, right? The width is still the same. It's still 0.5. It's still 0.5. And we know how to get that. Isn't delta x just the start, take away the finish over n? 3 take away 1. Divided by 4 strips, which is 0.5. So there's the calculation that we get with delta x if I needed it. I put down the first strip, 1, 1.5. That allows me to calculate what the midpoint would be, 1.25. Once I do that, I can go to my calculator and create the table. And then it's simply 0.5 times all 4 heights of the rectangle. And 8.625 is actually very accurate. And even although I've only used 4 strips, the correct answer, the exact answer, is that guy. Would you agree that's pretty good for 4 strips? 6.2 against, I guess, 6.7 if you round it off. Only 0.05 out, which is less than 1%. And that was with 4 strips. Can you imagine how good it would be if you had 24 strips? Go ahead, write a program. Don't do it by hand. How's that looking, guys? Any questions? Oh, I've got some chat, so that may be some questions. That's the... Makes sense, yeah, good. Now, the questions change, but the only thing that really changes is the function might have 10 strips, which means you do what I just did, but you do it 10 times. It might be that you don't have a formula. If it's one of those graphs, don't you just click on the graph and read off the numbers that you need? Right? And so that's how you would get through that issue. And I think this is a really cool place to stop. And thank you for taking time that you didn't need to come here. Hopefully it's been useful. I'm going to hang about because there may be some people with questions that want at the end. Feel free to talk to me. I will edit the video so that they don't appear on the one that everybody watches.